In this video, we are looking at increasing and decreasing curves. So to begin, we'll look at some terminology first. So we'll look at what a stationary point is. So this is a point on the graph y equals fx where the tangent is horizontal. What that means is that the gradient is 0. Now it could be a maximum point, a minimum point, or a horizontal point of inflection. So a maximum point goes up and then down. A minimum point goes down and then up, and then a point of inflection goes up and then continues to go up. Now, a monotonic increasing or decreasing is a function that is always increasing or always decreasing. So we're going to use the first derivative to help us identify graphs that are increasing, decreasing, and where the stationary points are. So if the derivative of the function is greater than 0, we know that the function is increasing. If the derivative of the function is less than 0, the graph is decreasing. And if the derivative of the function equals 0, that is where there is a stationary point. So again, a monotonic increasing or decreasing function is increasing if the derivative is greater than 0 for all values of x, and it's monotonic decreasing for all values less than 0. So here we have our first problem. So for what x values is the function here increasing? So the first thing we need to do is differentiate it. So I'll write out our function. And now we differentiate it. So the 2 comes out the front to multiply by -2, and then the power decreases by 1. The x is a power of 1, so it disappears, and we're left with 8. Now, a curve is increasing when the derivative is greater than 0. So we're going to try to find our values where our minus 4x plus 8 is greater than 0. So minus 4x plus 8 is greater than 0. At this stage, it becomes just a regular inequality that we need to solve. So minus 8 from both sides. We get minus 4x is greater than -8. We divide by -4. Now remember, with an inequality, if you're dividing by a negative or multiplying by a negative, the sign flips. So x is going to be less than 2. So what this is meaning is that the curve is increasing when x is less than 2. Alright, so that's all that means. So we're going to look at our next problem here, and this time we're trying to find some stationary points. So again, we follow the same kind of steps. Here's my function, and we need to find our derivative. So let's differentiate this. Now, again, stationary points are when our derivative, so in this case, is 0. So, knowing that, we can say that 0 equals 6x squared minus 18x plus 12. Alright, so now that we've done that, that's a quadratic, but let's do some simplification first. We know that there's a highest common factor there of 6, so let's divide everything by 6. So divide everything by 6, and we get x squared minus 3x plus 2. We then can factorize this, so we get x minus 2, x minus 1. Now that we've got that, remember we want to find our x solutions, so we're looking at what makes this equal 0 and what makes this equal 0. Alright, so for the first one, this x needs to be 2, and then for our blue square, this x needs to be 1. Alright, we now need to find, so what this is saying is at these x values, there are stationary points. Now points include an x and a y value, so we need to find our y values here. All right, so we need to find the y values. Now we do that by just substituting these x back into the original equation. So for the first one, if we have this, now remember that there just means I'm setting all our x values to 2. So what I get here is 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus 4. Now you might be thinking, where did he get all these numbers from? I am just using this here, and all I've done is replace all the x's with 2. Alright, now at this point you can put that all in your calculator and that comes out as 0. Now I'm going to do the same for our other point, y equals 1. So 2 times 1 cubed, 9 times 1 squared, 12 times 1 minus 4. And that comes out as 1. So our concluding statement, if you will, would be stationary points at 2, 0, because those are our x and our y values for one of our points, and 1, 1 was our other one. So there are 2 stationary points at these points. So here we have another function, but this time it's given us an unknown p, and we know there's a stationary point when x equals 2, and the question wants us to find what p is. So again, as always, we start the same way. We write out our function and we differentiate it. Now, we know there's a stationary point, and remember, like we did in the last one, there's a stationary point when our derivative function, the differentiated function, is equal to 0. So knowing that, I know that 0 equals 4x plus p, but I also know what our x value is. So I can say that let x equal 3, because that was up here. X equals 3. So now what I do is I can go 0 equals 4 times 3 plus p. So 0 equals 12 plus p minus the 12 from both sides. That cancels out, and I get p equals negative 12. So there, I found that. Now to recap what we just did, remember that the sign of the first derivative determines whether we're increasing, decreasing. So if your first derivative is bigger than 0, you know that the graph is increasing. Now, if the first derivative is less than 0, we know that the graph is decreasing. And finally, if it equals 0, you know there's a stationary point there, and those stationary points can be a maximum point, which you can see down the bottom, a minimum point, or an inflection point. Now remember, when you're talking about monotonic increasing or decreasing, this means if a monotonic graph is monotonic increasing, it's increasing for all values of x, and if it's monotonic decreasing, it's decreasing for all values of x.